Okay, grade 10s, here we go with surface area and volume. It's pretty straightforward. You guys have seen this before in grade 9, probably some in grade 8 as well. I try to simplify the formulas, and you'll notice in the formulas there that especially with volume, I use the same formula for, doesn't matter what shape it is. The only shape that I don't really follow the same formula for is a sphere, because it's kind of its own special thing. So if a shape is one of the special shapes, and I consider a sphere, a cylinder, a cone, all special shapes for surface area, they'll have a formula given. For volume, the only special shape would be the sphere. Everything else will fall under either the volume of a prism or volume of a pyramid formula, and I'll show you how those work. And then you've got your general formulas, the area of a triangle, the area of a circle, area of a rectangle. Those are used to build all the other formulas. So here you go. We've got the surface area definition is just the area of all the sides of an object added together. So picture painting the outside of a box. How much area would you cover? Volume is the capacity, or how much that object will hold, or how much that physical space that the object occupies. Again, you can just picture how much water could you put into that same box that you painted the outside of. So they're talking about two totally different things. One is how much surface it can cover, and one is how much it'll hold. Okay, 2-dimensional versus 3-dimensional. So look at the sheet of paper you're on top of. Put your hand on it. That's 2 dimensions, right? It's pretty flat. But 3 dimensions take a whole stack of paper and stack it up. That's the volume. That's the kind of the difference. That's how you got to almost envision it. So this first example here, we'll go like this. I'm going to do the surface area and volume for all these, so I hope I've got enough space for it. If I don't, we'll just squeeze it in somewhere. So on this guy here, we're going to do the surface area first, and it's surface area of a cylinder. And this is a situation where it has its own formula. So the surface area of a cylinder formula, if you look it up, it's going to be 2 pi r squared, because there's 2 circles, top and bottom, plus 2 pi r h. Now, if you think about this is the circumference of that circle, so the distance around that times the height of it. So imagine taking that and cutting that open and unrolling it. You just have a big rectangle like this. So the circumference is like your base, your height is your height. So you've got your base and your height is what's happening, but really the base is 2 pi r, your circumference. So that's where that formula comes from. So it's kind of like the area of a rectangle plus the area of 2 circles. So pretty straightforward. Just plug in your values, and that's really all surface area and volume is understanding what formula to use. Plug the numbers in, you get your answer. So we go 2 times pi. The radius would equal 2, because this is a diameter. So 2 squared is 4, plus 2 pi times the radius is 2, times the height is 6. You throw all that into your calculator exactly as it is, you can end up with an answer of 32 pi. I'll put that down, 32 pi, which would be totally okay by me, unit squared. Or, pump that in, 100.5 units squared. So there is how difficult surface area of a cylinder is. So now let's do the volume, because this is the first time you guys will probably see the way I look at this. This is a prism, right? We're talking regular polygons. Regular polygons means the same shape throughout, equal side lengths, all that kind of stuff. So this is a prism, and a prism by definition is just that the one shape, in this case it's our circle that we already kind of outlined, goes throughout the object. It follows that same circle right through to the other side. It doesn't change size, nothing. right through. So that's what makes it a prism. If it was a pyramid, that circle would get smaller and smaller and smaller until it got to a point, and that would become the pyramid. So if you look on the formula sheet that you've got in the Google Classroom, you'll see that the volume of a prism I've got written down is the area of the base shape times the height of the object. So this base shape thing, let me talk about this for a second. This can be the main shape. It can be whatever shape goes throughout the object is how I think of it. Okay, it doesn't have to be the base, like it doesn't have to be sitting on it. It can be laying horizontally and it still goes through it. Okay, so the volume of this guy, well, let's take the area of the base shape. The area of the circle is what I'm calling the base shape. That's pi r squared. So there's from your general formulas. So this equals pi times r is 2 squared is 4, so 4 pi. So I'm going to take that and I'm just going to throw that over here. That's this guy right there. So that equals 4 times pi times the height of the object is 6, so 24 pi, or put that in your calculator and you should get 75.4 units cubed. So again, pretty straightforward if you know what shape you're looking at. Okay, so there's two. There's the surface area one, which was one of our special shapes, and then we've got the volume of a prism, where the first time we've seen what this area of the base is. So now this formula will work for any prism. Same with the pyramid formula, it'll work the same thing. Okay, so let's do that, and then I'll jump to another example here. So here's a pyramid. This is the first time we do a pyramid. So same thing, we'll try to squish in the whole thing here. Let's go to surface area first. So surface area in this case, you'll notice there's no special formula for this. So you got to look at it, and the definition of surface area is, again, just the area of every side added up. So when I look at this picture, what I picture, and you should be able to see the same thing, is we've got a square base, so the area of a square, plus the triangle that make up the sides. There's 4 of them, so I'm going to say 4 times the area of the triangles, whatever the area of one triangle is. So I just made up my own formula because that's by definition what it is. So when we go and do this now, the area of the square, 6 times 6, base times height, we'll go 6 times 6 plus 4. The area of a triangle is base times height divided by 2. So if I'm looking at this triangle right here, this is the triangle I'm looking at, right there. The base of that triangle is 6. The height of that triangle is 5, and I have to divide it by 2. Now I'm timesing by 4, remember, because there's 4 of those same triangles. So now when we go and calculate all this out, we get 36 plus 60. So the surface area equals 96 units squared. So there's your answer for the surface area of that pyramid. No formula, just using the definition. Add up the area of all the sides, okay? So let's jump if you can, if you're still going here. Let's do the volume. Now this is a pyramid. Whoops. Let's say that. This is a volume of a pyramid. So the volume of a pyramid, the formula again, if you look on the formula sheet, says the area of the base times the height, and the only difference between a pyramid and a prism is whatever your answer is, you divide by 3. Okay, so in this one here, I see the area of the main shape, or the area of the square. I'll just call it the area of the square, because that to me is the main shape. It's that square, if you can picture it, is going smaller and smaller and smaller until it comes to a point up here. So here I'll draw it in with a yellow, so you can see like right here I see this square still, but it's a smaller square. So that to me is the main shape. So the area of the square times, is equal to base times height, or side squared, or length times width, whatever you want to do it as, is 6 times 6. So we get an answer of 36. There's the area of our base. So when I go and I put that back over here in the formula, I get the volume of the pyramid. Remember, we know this answer is 36 times the height of the object right here. Well, that's that guy. Not the height of the triangle on the side, but the height of the actual object, the vertical height of it, is 4 divided by 3. Okay, so now here's something to think about. If this was a cube with a square of 6 on the bottom that carried through, if it was a prism, there would be your answer, 36 times 4. So the only difference is it's a pyramid. It shrinks. So we're going to get is 48 units cubed. So whatever unit it is, centimeters, meters, yards, feet, would be 48 of those cubed. So there's how the volume of a pyramid works. Again, you see, the formula is you kind of make up the formula on your own using those general formulas like we did here, the square, and then back here we used a circle. Okay, so if it was a triangular base pyramid or something like that, you could use a triangle, or think of an ice cream cone. That would be a pi r squared times height divided by 3. You'd use a circle again. It depends on the shape. So one more. Let's do this guy. This is a doozer. Okay, so we've got a pentagonal prism. Okay, now I don't know how many of these in your life you'll ever do, but they're just a fun thing. And that's the other side part is, you guys know that you're probably going to pump this into a calculator, and there's some formulas. So it's not so much about the actual calculating of it. It's about using a formula in any sense, okay? So being able to, you're given a formula, some random formula, and you put the proper numbers in the proper spot. That's more what this is about. It's not about getting the right answer. Okay, can I take a formula? Can I put the numbers that it gives me into the right spot? That's what it's about. Okay, so the surface area of this guy, again, there's no special formula for this, but I can see the triangles on the bottom. So I got one there, but I got 1, 2, 3, 4, 5 of these guys, right? You can see if I keep drawing them out, how those would make up the area of the bottom. So I got 2. So I'm going to try to write this formula out here for myself. So I've got base times height divided by 2, a triangle. I got 5 of those triangles, and I got a top and a bottom. So I'm going to times that by 2. Okay, so again, the area of a triangle is base times height divided by 2. I got 5 of those triangles on the bottom, and I have a top and a bottom, so that's where the times 2 is. Plus, I'm not going to have enough room here, so I'm going to squeeze it in. I've got 5 rectangles on the sides. So I've got a 5 plus, I'll move it down here, 5 times, we'll call it base times, I better not call it base times height, I'll call it length times width. Length times width. So there's kind of the formula, as silly as it looks, for the area of this object. So we'll quickly do this. Surface area equals the base of the triangle, it says is 2, times the height of the triangle is 1.4 divided by 2, times by 5, because I have 5 of those triangles on the bottom. That makes up the pentagon. All 5 triangles make that area up. And I have a top as well. That's the exact same. Plus all the rectangles. 5. The length of the rectangle might be 2. And the width, or the height of it, I guess, we can call 4. And maybe that's what I should do here. I'll erase this, and I'll call this width for that 4 here. We'll call that there. Okay, so now when I pump this all in my calculator, this 2 cancels with this 2, 10, 14 plus, we got 20, 40, so we got an area, surface area of this pentagon of 54 units squared. Perfect. So you can see a little bit more involved on that one, but the volume of this guy, this is the volume of a prism again. So it's just the area of the base times the height. Times the height. Well, we're gonna steal some stuff here. We got our area of our pentagon. Area of the pentagon, we know, is base times height divided by 2. There's the triangle. Times 5 of those triangles. Now I don't have to times by the top because I only need the one, just the base shape. So again, 2 times 1.4 divided by 2 times by 5. So we got area of the base 2 times 1.4 divided by 2. Whoops. Times by 5. So there's the area of our base shape, our area of our pentagon, times the height of this object, which is 4. This is our height going in here. So I'm just going to cancel out the 2's, and we get the volume equals 5 times 4 is 20, so 28 units cubed is the way I look at that one. Yeah, hope that sort of makes some sense. I don't know how much sense it's going to make, but hopefully some.